So yeah, this is really unexpected, so you're going to have to bear with me. Haven't done this for a while because of something that's happened, and this isn't my presentation. So now I'm absolved of it being any good. We can move on. Right, so we're going to talk about Kubernetes as a service. We're going to go on a little bit of a journey. We're going to go from a journey of doing everything manually to doing stuff through GitOps. We're going to investigate a couple of cool projects like that you may have heard of. One called Cluster API around provisioning your clusters, bootstrapping your Kubernetes clusters, and one called Flux, which is about applying workloads through a GitOps workflow. Okay, so let's just start with the ecosystem around Kubernetes is massive. Like, you know this. Is everyone here like work with Kubernetes? Oh, you know, there are people that don't. No, it's huge, right? Like this is going up all the time. Like, this number's probably old now. 100+ distributions, hosted services, installers. This is how you create your clusters. This is how you just create some infrastructure to run your applications, and no one really cares about the Kubernetes cluster, right? It doesn't provide you with any value. It's your services that run on top of there. So we want to try and make that provisioning and that service that provides you with your cluster to run your workloads on as easy as possible. You want that to be super slick, super easy, so you can get to the value that your customers and your businesses need. So with all that, why am I going to talk about another tool? Like, you've got all these other options, like all of this stuff. You could just use that. But no, of course, we need one more. So hell yeah. I mean, this isn't my terminology. I would not say that ever in my life. But this is Kim's, and he says, hell yeah. So, Cluster API, right? Is anyone familiar with Cluster API? I bet more of you maybe are familiar with Terraform and Ansible, for stuff like that, for provisioning stuff. So, at D2IQ, I know I shouldn't really mention the company too much. We're going to talk about open source projects. I'm just going to do this little tiny bit about D2IQ. We went on a journey that probably some of you have gone on. We had a V1 product that was built around Terraform and Ansible. Terraform for provisioning your infrastructure in a nice declarative way. Ansible for running playbooks, scripts, to actually turn your Kubernetes cluster into something usable, right? And then we hit with some roadblocks with that. One of those roadblocks was, how do you continually reconcile what's happening? Because when you're running on a cloud, or if you're running on premise, things go wrong in your infrastructure, right? Machines die. Amazon kill a host. You lose VMs. You lose nodes. If you're using something like Terraform, how do you recover from these things? And there's something in Kubernetes which all of you will be aware of, like the controller model. So applying the controller model to infrastructure provisioning makes sense. So we can use the way that Kubernetes manages or orchestrates workloads, i.e. pods, etc. We can use the same controller model to actually provision your infrastructure, to actually provision your Kubernetes clusters. And you get all those benefits because it's continually reconciling. And this is what Cluster API does. It provides an API, a declarative API. The real power of Kubernetes is the declarative API. You heard about it from the two guys that were talking before. Like, the Kubernetes API is the power. The orchestration is just an implementation, right? It's just a byproduct of a really cool API model. So Cluster API builds on that. It provides CRDs, you just heard about that, to provide a declarative way of describing your clusters, what you want. And then controllers, or you could say operators, kind of interchangeable a bit, to actually go and provision those clusters. Provisioning, upgrades, and day-to-day operations, like how do you scale your node pools? How do you roll out new machine images to your nodes? All these things are all handled by Cluster API and by the controllers. As I say, via declarative API, with that same model, you declare what you want, it reconciles, it continually watches what's happening in your infrastructure. Is the real state what you want? If not, bring it into balance, right? Reconcile it back in. So, yeah. And through the API, there is a large provider integration. It's, again, growing all the time. But because there's an API, and there's a really strict API around how the different providers interact with the core of Cluster API. So that allows extensibility through pluggability, effectively. You can deploy different providers, but have the same experience regardless of provider, right? Regardless of cloud provider or on-prem. And a lot of it is based on kubeadm, which is the way that machines are bootstrapped, machines are joined to clusters via cloud init, things like that. Okay, so there's a lot of providers. I mean, we haven't even mentioned bare metal. Oh, we have, yeah. So pretty much whatever you use, there will be a provider, and not always, of course, but you can go and write your own. We at D2IQ have written our own for some things, for certain customers. They're actually really easy because the API is really well defined. What you need to provide what you need to adhere to as a provider is it's simple, right? You do the bits and you return some state back to the core of cluster API, and you have the same user experience. It's nice. So like, does this cover all of your use cases? Like, any of you not covered by this? I'm sure some of you will be. Some of you will be cool and go, I use a different provider. No. Yeah, it covers everyone. Nice. Yeah. So we're going to go through, normally I would do this as a live demo, but because I only learned about this like an hour ago, I'm afraid it's going to be like boring slides. Like, you're going to see shell commands and output in slides. I mean, that's possibly the pinnacle of my presentation that I've ever done. So we need a few tools. Like, this is work. You can work through this example yourself as well, right? This is actually something that would work on your laptop or on your machine anywhere. So if you want to, we can share the code afterwards. It's really quite simple. There's a few tools. Cluster Cuddle, kubectl, kind. So we all know kubectl is how you interact with the API through the CLI, right? It's you know that tool. Kind, does everyone know kind? Kubernetes in Docker, yeah, a few of you. So if you ever, it's a really great way, by the way, just as an aside, kind is a way of spinning up Kubernetes on your local machine, on your local laptop, just in a Docker container. It's totally isolated. It runs containerd isolated in there, so it's separate from your container runtime on your host. And it's just a great way of developing against and experimenting with stuff and learning as well. Like, we use it for all our learning stuff for new customers. We'll give them a kind cluster and give them stuff to work through. They don't need any other resources, right? It's nice and easy. So yeah, there's other ones. It's similar to like Minikube and K3s or to some degree. And then there's also Cluster Cuddle, which is, as every good project needs its own, CLI tool. And Cluster Cuddle is a wrapper around. You could do everything through kubectl, but it just provides a nicer UX on top of CAPI, so you could work through it. Linux or Mac, it probably works on Windows as well, but yeah. And you need some credentials for your infrastructure provider. That's it. So I'm going to whiz through these because I say, not that interesting really, but yeah, you create a cluster. If you've not seen kind before, that one command, kind create cluster, this is how you create a cluster on your local machine. It's super simple, right? And you can also do multi-node clusters. Ooh, like it's really, really nice. So I do advise you to have a look at that if you've not done before. Yeah. Oh look, there's a Docker container, that's what it does, and there's some nodes, and you can have multiple nodes in kind as well. So now we've got a Kubernetes cluster. Now this Kubernetes cluster is local right now. We call it in the CAPI world normally a Bootstrap cluster because the way that CAPI, Cluster API, CAPI, the way that it works is actually to use the same way that it will be managing the workload cluster at the end to actually do the initial provisioning. All right? So it needs a Kubernetes cluster. We've created that through kind. We're then going to deploy these controllers, these CAPI controllers. And this is like one command. Cluster Cuddle, init infrastructure, Hetzner. We're using Hetzner because someone told me Hetzner was popular. I've learned something different today. So although I love Hetzner from, someone sold it to me earlier, it's amazing. We could have done it with Azure, we could have done it with AWS. We've just used Hetzner today just as an example. Yeah, so and you can see it's actually deployed more than just Hetzner. So actually, if we look down the bottom, we can see we've installed an infrastructure provider, infrastructure Hetzner. Okay, that's what I asked it to do. But we can also see it's installed control plane kubeadm provider. And it's also installed Bootstrap kubeadm provider. Oh, and it's also installed Cluster API provider. So the way that CAPI works is to deploy multiple deployments that each act on their own CRDs. So each one of these providers has its own CRDs. The Cluster API one is the core one. That's the one that, as a user, you can go and inspect the state of all of your cluster through, because these other providers adhere to the API that CAPI says as a provider, you need to do this. You need to expose these fields. You need to go through these workflow states, etc. So you can have the same UX regardless of provider. And it says at the bottom, your management cluster has been initialized. I called it a Bootstrap cluster. We'll come back to management cluster. But effectively, you can run this same command actually against any Kubernetes cluster. Right? This one command, as long as your kubectl set up, kubectl config is set up correctly, run it against any Kubernetes cluster, existing cluster, obviously, and you end up with a management cluster. We've just done it as a Bootstrap because it didn't have anything to begin with. Right? And yeah, there you go. It deployed something. A controller manager. Every provider has its own controller manager. So when you do this, it feels quite a bit odd at first. Like, why am I deploying 5, 6 controller managers to spin up one cluster? And that's because of the way that it goes through, the way that CAPI separates out infrastructure, creating your machines, creating your network infrastructure, etc., your VPCs if you're in AWS, etc. It separates out the infrastructure provisioning from the Kubernetes Bootstrap provisioning. So you can plug in different infrastructure providers, and then actually use the same way of bootstrapping your Kubernetes cluster, which is normally kubadm, right? Which is to say that's the way it generates cloud in it. That's the way it actually spins up the, or creates the manifests for the Kubernetes core components to run. It joins the machines. kubadm is an awesome thing, right? It's a great tool. So we're going to move on. We're going to keep going with our Hetzner example. And we talked about every provider. If we're going to create a cluster, we need to provide it with some credentials. In this case, Hetzner just needs an API token. You go to the Hetzner console, create an API token, and you put it in a secret. Again, we'll talk about secrets a bit more when we get to the GitOps bit, if we get there. I may be overrunning, who knows. Secrets management in a GitOps world is quite fun as well. It could be its own talk, by the way, rather than the whiz-bang we're going to go through. And then come back to one of the other tools we said, ClusterCuddle. And this is one of the pieces of UX that ClusterCuddle, the Cluster API CLI tool, this is one of the things it provides with you. It's to go and generate these cluster resources. So we know when we work with Kubernetes, right, we end up with a number of different resources. We don't end up with just one. We end up with, if you're looking at a deployment, you end up with deployment, and you'll end up with secrets, and you end up with persistent volumes, and you'll end up with config maps, and you'll end up with RBAC rules. So this is a one-line command to go and generate all these resources for Cluster API. You'll get a cluster. You'll get, I can show you what we get in a second. But this is tooling. Each of these things is done via a templating system. It's very simple. It's just done through environment variables. Currently, there's some plans to make that a lot better. It's in the works. It will get better. But these are the variables that are available through these templates. So I've literally just said here, I want to create a cluster based on Hetzner. You can create your own templates as well, which is another really cool, powerful thing of CAPI. These are just the default out the box or upstream ones. So I said we export our variables. So if we went back, you can see these are the variables available, and I've exported them as environment variables. And then I've created it. So we can see we've used ClusterCuddle, generate cluster. This time I haven't done the list variables, but that's generated the resources, and then we've kubectl applied it. Yeah, you know this flow. And we can see it's created a number of different things. This is actually a subset of the things it's created. It's created a control plane, a kubadm control plane. It's created an hcloud, that must be a Hetzner cloud machine template, an hcloud machine template. So multiple things that are happening here. So kubadm control plane in Kubernetes is saying, this is the definition of your control plane, and this is how you're going to generate via kubadm those cloud init scripts for your potentially highly available. Most people, hopefully, run with more than one instance of their control plane. They have multiple nodes in their control plane. So this is Cluster API goes and orchestrates that for you. So when you've defined a kubadm control plane, it will go and create the first machine. It'll bootstrap your etcd cluster. When that's ready, spin up the next one. Actually, it may even do the next two at the same time. I can't remember. Join those etcd nodes back into the cluster. Now I've got a highly available control plane. All I've done is define one resource via CAPI. The CAPI controllers have done all the work behind it. I think it's cool. And these are the ones down the bottom, machine templates. So we separated them out. I mentioned earlier about the separation between infrastructure provider, the way you're providing the machines and your networking, your disk, your etc. That's the infrastructure provider. And that's what machine templates are. Machine templates are, this is what each of your machines should look like. right? Apply that X number of times. Just like with deployments, you say number of replicas in a deployment. Here, you say the number of deployments, sorry, the number of replicas in a machine template. And what's also cool about that, I don't know if you know the kubectl scale command. This works with that. You can scale node pools by scaling the replicas in a machine template. That's pretty awesome. I want 10 nodes. Kubectl scale hcloud, actually it'll be a machine template, Jimmi, 10, right? Or replicas equal 10. I've now scaled it via kubectl declaratively, and then controller, a cluster API has then gone and applied that. It adheres to the same conventions as every other Kubernetes API, effectively, which is really nice. One thing it doesn't do is deploy things like CNI, CSI, so your network interface, your storage interface. It's not opinionated. Now, that's good and bad. So out of the box, if you deploy just a cluster like that, nothing will work. Your nodes will never become ready because there is no CNI in there. There's no container networking running. So you have to go and choose to do it yourself. In this example, we're literally just applying Cilium. Cilium are out here. We like Cilium. We also like Calico. So yeah, they're both good out there. Applying that, and so you're initializing your CNI on your cluster. It may feel a bit weird that it's a second step, but remember that when you're a provider in like the CAPI world, that you want it to be pluggable. Everyone has different requirements, right? You can't be too opinionated with an upstream project like this. You have to allow space for flexibility in your deployments. So yeah. And the other thing, because we're on Hetzner, this is the same with now anyway with Kubernetes. The Cloud Controller Manager is out of tree. So Cloud Controller Manager, the part that interacts, that when you create a service, it's a load balancer service, and it goes and creates the actual cloud provider's load balancer, your ELB on AWS, etc. This is Hetzner's version. It's called CCM hcloud. So if we're running in a public cloud, especially public cloud, we have to go and provide a cloud controller manager. Otherwise, we end up with services which are kind of inaccessible into the cluster and not that useful. So yeah, we haven't done CSI, but this is just showing you there are other things you need to do after you've done the CAPI creation, right? And then this is cool. I love this this command, like describe cluster, and you can see a whole tree of all the resources that have been created, and you can see the states they're in, and you can also see we haven't done any failure states here, but you can also see when things have failed. Right, it's just Hetzner UI. I've never even seen that, but it looks quite nice. Right, and then there's one final part, and this may again sound a bit weird. I've created a cluster, but right now, all my controllers, if you remember, when I did the cluster cuddle init, I deployed the CAPI controllers on my Bootstrap cluster. So they're all running on my local machine in my kind cluster locally. But I don't want that anymore because I want to shut my laptop and go home for the day. I don't want it to be connected anymore, right? Okay, so what we're going to do is we're going to use cluster cuddle again to move these resources, these CAPI controllers, up to your workload cluster. So then it becomes self-managed because the controllers that are managing the life cycle of the cluster itself are running on that same cluster. That's pretty cool, I think, as well, because you don't require external resources to do it. When I said management cluster, I don't know, we got time. It's fine, we'll come back later. So TLDR, what happened? This is quite a fun slide, I think. One, we created a kind cluster. We created the CAPI controllers. We deployed the infra provider. We deployed the Kubernetes cluster. That went to Hetzner and created the infrastructure. Deployed Kubernetes via kubeadm, right? That did all the bootstrapping. We then have to get the kube config, because how do we interact with this new cluster otherwise? We deploy the CNI and the Cloud Controller Manager. We do the move. And then we can get rid of that Bootstrap cluster. So what we've done, it sounds like a lot of steps. Most, or a number of companies that are now providing products around, and not mentioning my company, obviously, a number of companies have made that really easy, right? Rather than it being an 11-step process, it's like a one-step process. So look at those where there's value add. That's, that's my kind of one takeaway. Each vendor, if you do go to a vendor to buy something, they bring value on top of the open source tooling, which tends to be a bit more less opinionated in workflows. Okay, so we've just created some clusters with CAPI. Well, I've got one cluster. For some people, that's fine. for most people or most companies or users, you want multiple, right? You need more than one cluster for various reasons, But so maybe we want multiple self-managed. When I say self-managed, do you remember that means we've moved the CAPI controllers onto the cluster itself. It's then managing its own lifecycle. The controllers there are managing its own infrastructure and its own scaling of nodes, self-healing of nodes, etc. And so if we're in a GitOps model, GitOps meaning we define what we want to happen via Git. We write some files, we commit it, we push it up to Git, and we can do the normal developer workflows of reviewing pull request reviews, etc., before they're actually applied. So we can actually define these resources via YAML in Git or JSON. You can use what you want. Define them in Git. You can also do that kind of say, when you want to do an upgrade, maybe you go through that review process. Because there's one thing that Kubernetes API doesn't give you. Like, as a user, I can't go, I want to scale this cluster, and I can't define that I want to scale it, and then someone else come in later and go, yes, you can, I approve that. These are the workflows that are not necessarily built into the Kubernetes API. Are there when we use other tools such as GitOps, right? That we can go through these approval processes and add value through that process that way. One thing though, like, what do I do with secrets? Because if I'm writing on my cluster state, one of the things we talked about there was just one secret we created was the Hetzner credentials. Well, what do I do with that? Like, I can't just put that into Git because I could restrict access to that Git repository, but I don't want necessarily everyone, especially if you have an SRE team or an infra team, they don't want to share those. They really don't want to share those credentials with us developers, right? So what do I do? And so there are multiple options, and I'm sure you've all probably got your own. Like Vault is well used. It's a brilliant one. If you don't have an external repository, if you're like you might be using Secrets Manager and AWS or whatever. If you don't have that, you can use encrypted secrets. So if any of you have worked with things like Travis CI or Circle CI or upstream CI systems, they kind of trailblaze to some extent encrypting secrets. So you can put in confidential data into your Git repository, and it can only be decrypted by the cluster itself. So as a developer, I can't go in and see my Hetzner credentials, for example. So that's another option for a more lightweight process, not necessarily too scalable, but it does work. But I've pushed it into Git. Now what I've got to do is create a Bootstrap process. I've got to create a pipeline for that Bootstrap process. I've got to create a CI pipeline that applies those, 11 steps that we did before. I've got to script all that. And I've also got to make sure I've got the right steps in place, the right kind of, when do I move to the next step? Because I can't sit there and watch something. This is a machine. Now, how do I tell the machine it's ready to move to the next step? So you do need pipelines, but they're a bit tricky, right? And the other thing is that every cluster is then self-managed. So what I've then had to do is I've had to distribute these credentials, because it's self-managing, it needs to have the credentials to talk to the cloud provider API. I've had to put those credentials in every cluster. I don't really want to do that, as well as I don't want to deploy extra resources just to manage itself. It needs, might need another node or two just to deploy these controllers, depending on what resources you've got in there. Where's the, that costs money. Why do I want to do that? Yeah. So, centrally managed. Wait a second. When at the start, I created a Bootstrap cluster, and it said management cluster or something, created successfully or initialized. And I said, you could also deploy the same cluster cuddle init command against any Kubernetes cluster. And that ends up with what we call a central management cluster. Okay, so I can manage multiple clusters through the same management cluster. Okay, I need one cluster, and it can do it across multiple clouds because I can deploy multiple infrastructure providers. It can deploy on-prem, as long as it has access to the respective cloud provider endpoint APIs. Then we can just use one cluster to deploy, or we could have like sharding, we could scale, we could do different stuff, right? But what I'm trying to get to is, you can still define your clusters in Git. You can still use the same way of managing secrets in the same way as we talked about. We have one management cluster, and we have one pipeline. Like this pipeline that applies this definition, literally applies this definition. We can skip steps I'm making up numbers now, like 1 to 7. And we can also skip steps 9 to 11. I don't remember what they are. So, what I mean is we only get a couple of steps that are necessary. And those steps are push the resources into Git, something, which we'll talk about in a second, a pipeline in this case, pulls those resources in to the API server. CAPI controllers do all of the heavy lifting to go and create them. A much more lightweight process, right? What was that last one? Oh, yeah. So the management cluster controls the life cycle of all these clusters. So that's a basic little diagram. Either all these standalone clusters that look after themselves, or you have one central cluster that manages all these other ones. We've only got a few minutes. So, yeah. There's a load more. We talked, like the start slide had, there's 100 distributions and there's 1,000,001 different cloud providers. That's just the start. Then the next stage is, well, now I've got a Kubernetes cluster. How do I manage the workloads on this Kubernetes cluster? And we can apply automation to manage and deploy the lifecycle, manage the lifecycle of our workloads as well. And we're going to use the same approach. We're going to use GitOps in the same way. We're going to use Flux. Anyone here familiar with Flux? Cool. Or Argo? Anyone familiar with Argo? Okay, better balance. That's nice. Right. Yeah, these are two great systems. Right, applying resources from a Git repository into your Kubernetes API. Like, it sounds so simple, but it adds layers of on top of that. There's some functionality I really, again, recommend. We're going to be running out of time, so I haven't got much time to talk about it. I really recommend you read up on these. They are awesome, open source, upstream projects. Great communities as well, by the way. Really welcoming communities, just like Kubernetes, but Flux even more so, I think. Yeah, I think we could probably skip. I think we can probably finish there, because otherwise I'm going to be just reading quickly, and that's not much fun. So, yeah, let's go. Questions?
Thank you for jumping in. We already have some questions. They come in via Slido. First thing is, how does crossplane compare to CAPI?
Yeah.
Yeah.
In some ways, they're equivalent. I think crossplane actually ends up with layers of functionality. It does more, basically. Crossplane does more. Crossplane also manages, as far as I'm aware, it manages other kinds of infrastructure, other service kinds. So you can do the same thing through that. The reason we went with CAPI, one of the reasons is because it's more a core part of the Kubernetes ecosystem. It's part of the Kubernetes SIGs. It's more integrated into Kubernetes. It has I think, in no way am I bashing crossplane at all, because I don't know, but the governance system around it is around CAPI is so tight. And the Kubernetes ecosystem. And that's one of the reasons why we support it more, is because of the governance, the welcoming nature of the community. So functionally, I think crossplane does actually more. Huh?
Okay, now questions are coming in. Is the solution easy to scale from the API provider's point of view?
Yes. Well, okay. There are problems with it, right? So it depends what you mean by scale. From the API provider's point of view. So with every scaling, like whenever we're with Kubernetes, the way the controllers work is they're watching resources. They have a cache. Every controller has a in-memory cache of the resources it's watching on the cluster. So when we talk about scaling, if we're talking about multiple clusters, the providers are going to have to have more resources to be able to handle that. They also need to be able to run multiple concurrent workers. So in the way that a controller works, a very simple control loop that runs from beginning to end, exits, next one comes in. You have to run multiple concurrent workers. So another way of scaling is to run more provider workers, right? But then the biggest problem that we found actually is scaling to a point where the actual cloud provider can deal with what you want. So we're doing testing around spinning up 1,000 clusters in AWS at the same time. Some of our customers want that. Crazy, I know, but they do. Anyway, and actually AWS can't keep up with it. And so actually what the CAPI providers have had to go is, whoa, I have to now work around, for example, API throttling from the upstream cloud providers. How do we do this? How do we scale this across multiple accounts? How do we work around the restrictions that the cloud providers put in place, as opposed to it being a problem of scaling the API provider, the controller inside Kubernetes? It's more the actual cloud provider. Yeah.
How would one install Cilium through GitOps?
Well, that's a good question. I'm more like a Calico person, to be honest. I don't know. Is anyone from Cilium here? Yeah. How would you deploy Cilium through GitOps? Do you have an operator? You.
Okay, so you might discuss that later.
I would say, I don't know if you have an operator. If I talk about Calico rather than Cilium, sorry, like CNI. So with Calico, there's a Tigera operator, and then you would deploy that via resources. If Cilium has an operator, it would be the same approach, I'm sure. And then you would just apply your installation resource via GitOps. It's just a resource, and then the operator does the deployment. I guess Cilium does something similar, but I don't know. I feel bad now. Oh, it's awful to be asked a question, and you're up here, I don't know. That's really bad. Thanks.
How does CAPI compare to Gardener?
Gardener was maybe earlier. I'm not too like all these questions around comparing projects. I never really like, because all these projects are awesome, and whenever I feel like I get nervous about going, well, CAPI's better at this and Gardener's better at this, because I never want to bash any of these cool projects, right? They're all doing a great job. So I really just like to focus on the benefits of the one that we've got that we're using. What I find again is that CAPI has got to a point where the evolution of CAPI is very public and very contributed by a large number of different companies, right? So it's not single vendor. I think Gardener's a bit more single vendor effectively driven. Again, if I'm wrong, please correct me. I never want to say anything bad about providers like that, so please tell me when I'm wrong. And so, yeah, what's come out of that is much tighter use cases, much tighter designs that a community can read, listen to, contribute to. So again, I'm just very supportive of the CAPI community, I guess. You know. Again, please tell me if I get anything wrong. I'm never bashing anyone. Yeah.
Okay, that's it with questions.
Great.
Jimmy, thank you so much for being here and for jumping in so spontaneously. Thank you,
Great.
Jimmy.
Thank you.